everyone. This is basically an introduction to using inductive reasoning skills to find patterns and to write functions based on that patterns with use of conjectures. So we're using conjectures and inductive reasoning. So the first one example we have, it says use the pattern below to find the next three numbers of the pattern. And so basically this one is going to be hard if you don't know your cubes. Because right away you should notice that if you don't overuse the calculator, that we know that 1 cubed equals 1, 2 cubed equals 8, and 3 cubed equals 27. So what we want is the next three numbers in the pattern. That's 3 cubed. So that would be 4 cubed, 5 cubed, and 6 cubed. So 4 cubed is 64. 5 cubed is 125. And 6 cubed is 216. And that's just knowing your basic cubes, like you know your squares. All right, the second one is this one. It says use a table to answer the following. So we have x and y, and what we're going to do is use see what the differences are here. So the differences are 2 and 2. So if I made another one, so this is going by 1, so this would be 4. What do you think this number would be? And that would be 11. So what we want to do is write a function to represent what we are doing here. So since we're going by 2's, this is going to be something like y equals 2x. It means it's linear. So let's try the first one we have. We need to get a 5. So if I write 5 equals 2 times 1, to make this y a 5, I'm going to have to add 3. All right. So let's try another one. So if we have y equals 2x plus 3. And the linear ones are a little easier than the cube ones, but let's try to plug in 2. So if we have y equals 2 times 2 plus 3, that gives us 7, and that works. Like this one gave us 5. And let's check the 4. So we have y equals 2 times 4 plus 3. So that would be 8 plus 3, which equals our 11 for y. And so we're going to write y equals 2x plus 3. Okay, since a lot of times when you're doing these, it takes time to think about them. You can't rush through them. All right, the next one is this one. We're going by, we start with 2, 3, 4, and then we would have a 5 here. So if I'm going by 5, and then this is going to be 7, so the next one's going to be 9. So what's 9 plus 13? That's going to be 22. So now we have, this is not finite differences. But what we do have, and I'm going to look at this, we have 5, 7, 9 on this row. And then when you look at this part, we get 2's. So if these were the same on the first row, that would be linear. But since they're not and they're the same on the second row, that means it's exponential. So let's try y equals, since it's 2, x squared. So if we try that, and let's plug in our x. So the first one is 2, so let's plug in that. So we get y equals 2 squared, and that's equal 4. And we really need a 1. This is really like your y here. So to do that, you'd have to subtract 3. So from that, I'm going to make a conjecture, and I'm going to say, well, let's try this. Y equals x squared minus 3. So just pick one of these. Let's pick 4. And let's try that. So we get y equals 4 squared minus 3. That gives us 16 minus 3, which equals 13, which checks. And you can check one more. Let's check this one. Y, that's not going to work. Y equals 5 squared minus 3. So that would be 25 minus 3, which equals 22. So that does work. In all these cases, my y is really f of x. Remember, those are the same. So f of x equals what we first conjectured is x squared minus 3. Now we have one with some shapes. And so when I look at this, I'm counting 1, 2, 3. I have 2 of these. So I'm going to write this as, this is your stage 1, stage 2, and stage 3. So we could say stage 1 is 2 times 3 plus 2 times 1. Because there's just 1 right here. And we're trying to make a pattern. So let's try stage 2. So stage 2, I count at the top 1, 2, 3, 4. 1, 2, 3, 4. So I get 2 times 4. And then I'm going to do 2 times, there's 2 here. 2 times 2. So this one's actually 6. This is 8. This is going to be 8 plus 4 is 12. And let's do stage 3. I have 2 of these. So there's 5 there and 5 at the bottom here. So that's 2 times 5 plus 2 times 1, 1, 2, 3. 1, 2, 3. So that's 2 times 3. So that would be 10 plus 6, which is 16. So if you look at this, and I have to do stage what? 7th. I have to do stage 7. So if you notice in our pattern, these are the same. And stage 1 and stage 2 and stage 3 have these numbers. So if I were to do the 7th one, that would be 2 times something plus 2. We know this is 7. And we know this number is always 2 more. So this is going to be 2 times 9. Because you don't want to draw all these. So let's look at that. 2 times 9 is 18 plus 14. And that gives you 32. And again, these take a lot of time to think about. You have to think about it and work it out. And the last one is a common one. So I'll call this stage 1, stage 2, and stage 3. We definitely want to use these numbers here. You could actually call those your like X is 1, 2, 3. And then your Y is your output. So in this case, that would be 1, 4, and 9. So as you look at that, it looks like we're just squaring everything. So we know that 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. So if we did the next pattern, 4 squared would equal 16. And what they want is the 6th pattern. So you would just do 6 squared, and that would be 36. So that's kind of how you have to think about it. And it takes a while to get used to it, but the more you do it, it gets a little easier. Thank you. Have a nice day. Bye-bye.